All of us look up at the stars now and then. Most of us perceive them as separate luminous objects whose light reaches us from remote parts of the universe. But if you observe them much closer, you may see the real and more surprising nature of these bodies. And explorers keep discovering new aspects of stars that would stun anyone who has only just started taking interest in space. Generally, stars with only one stellar companion are the most frequent ones we come across in the universe. Such systems are referred to as binary and account for about half of all the stars known to science today. But what would you say if I told you there's a system of 6 stars quite close to our own planet by space standards, and the parameters of all of its celestial bodies are very similar to those of our Sun? And indeed, such a system does exist. Its name is Castor. Systems with this number of stars are rather rare. What we see while observing the stars are generally binary systems, that is, systems consisting of 2 objects. As for multiple systems, that is, those made up of 3 or more stars, they are by far rarer. There are 2 varieties of multiple systems, namely optical and physical. Objects in optical systems are located far from each other, but seen from the Earth they appear to be just one star. Objects in physical systems, meanwhile, are actually close together and are bound by gravity. Most physical multiple systems consist of just 3 objects. It is triple systems that account for about 70% of all systems of this kind known to us today. The Castor system, however, is noticeably different from the majority. Each of the 3 main stars in this system is a binary star. Thus, the total number of stars in Castor is 6. It is also highly unlikely that there are stars in areas unobservable to us in Castor's vicinity which are gravitationally bound to this sextuple system. The more components a multiple system contains, the fewer such systems there are in space. This means that systems consisting of 3 and more stars must be extremely rare in the universe. It goes without saying that we are far from possessing all data about multiple systems statistics. That is why we can't but admit that in theory there may be systems with still more components somewhere in deep space. Getting back to the Castor system, this is the second brightest object in the constellation Gemini. It is beaten only by Pollux, an orange-hued giant star. In terms of luminosity in our sky, Castor holds the 23rd place. The system is 50.88 light-years away from our Earth, and its age is estimated at approximately 200 million years. It was discovered back in the 17th century, and even then it was classified as a binary system. And later, astronomers managed to spot several other objects physically bound to it. The first and the main component of the system was dubbed Castor AA. This is a main sequence star of spectral type A15. It is about twice as heavy as our Sun, and its radius is also 2 Sun's radii. The surface temperature on Castor reaches approximately 9,140 degrees Kelvin. At the same time, the object's luminosity is 30 times that of our Sun. The second component's designation is Castor BA. It is of spectral type A25M, and its mass is 1.7 times that of the Sun, with its radius measuring 1.6 that of the Sun. Castor BA orbits its companion star Castor AA. It takes the 2 objects about 350 years to complete a full orbit around each other. It was later found that the eclipsing variable star YY Geminorum is also physically bound to Castor. It is a star of spectral type M.55e. Its mass is 0.62 that of the Sun, and its radius is 0.76 that of the Sun. That made it the 3rd component in the system, so it was rightfully designated Castor CA. This star follows an elongated elliptical orbit around the system's barycenter. Scientists estimate its orbital period at 14,000 years. As for its location, it is approximately 1,100 astronomical units away from its 2 companions. Each of these stars is binary, which means that each of them has a secondary companion of its own. Let's look at them. Castor AB is strongly bound to Castor A, and its mass is about half that of the Sun. Castor BB is a star of spectral type M25, and its mass is also about half that of the Sun. Castor CB is a star of spectral type M.55e and is slightly heavier at 0.57 Sun's mass and with a radius of 0.68 that of the Sun. Castor CB is almost identical with Castor Ca in its properties, as the surface temperature of both is approximately 3820 degrees Kelvin and their luminosity is less than 10% that of the Sun. All the 6 stars orbit around a common center of mass or barycenter, and their overall luminosity is 52.4 times that of the Sun. Castor AA and Castor BA are white stars. Interestingly, the former is 30 times and the latter 14 times brighter than the Sun. By contrast, Castor Ca and Castor Cb are typical red dwarfs. According to scientists, Castor AA and Castor BA are supposed to remain in the main sequence stage for at least several 100 million years. The red dwarfs, meanwhile, like Castor Ca and Cb, have a much longer expected lifespan. This is due to the slow process of thermonuclear fusion of hydrogen, and so they may last from several billion to tens of trillions of years. Scientists are currently busy looking for exoplanets in the Castor system. However, so far they have not been able to discover as much as a hint of exoplanets in the system. Perhaps the system is too young to have produced any, or else more advanced methods of detection are called for. It is too early to speak about other physical properties of these stars. It is quite difficult to study them because they are optical doubles and seen from the Earth only seem to be close, whereas it is an illusion. That is why special spectrometers are necessary to take care of accurate measurements. We can see all the 6 stars from our Earth as a single object, and it is located in the northern hemisphere in the constellation Gemini. The best time to observe them is in winter and spring. It is easy to locate Castor in the sky, as it is bright enough and can be found near a well-known asterism called the Winter Circle or the Winter Hexagon. This asterism is made up of Pollux, Capella, Aldebaran, Rigel, Sirius and Procyon. It is best seen in the night sky in northern latitudes in the winter time. February is the best month to observe Castor and Pollux. It's worth mentioning that Castor is a star system that leads a group of at least 16 celestial bodies. The point is that these stars move together and have similar velocities, and their age is similar. That is why they have been dubbed by scientists as the Castor Moving Group or Castor Stream. It includes such well-known astronomical objects as Fomalhaut, Vega, Alderamin, Alpha Libri and others. The question of Castor's stellar evolution still remains open. As I've mentioned before, most telescopes are incapable of revealing finer details of these stars, as they're too close together as seen from the Earth. According to some scientists, systems of this kind are formed as a result of a big star split into 2 components by centrifugal force. Others claim that they originate when one star gravitationally captures the other. There is also a theory of compound nucleus formation that suggests a molecular cloud's fragmentation with stars forming as a result. Then there is a theory involving protostellar disks that suggests sudden cooling of gas in a massive protostellar disk, so several stellar companions may simultaneously originate in one and the same plane following the disk's fragmentation. Be it as it may, most facts indicate that multiple systems originate in one place rather than from scattered sources. In the case of the Castor system, its components are believed to have been formed out of one molecular cloud in the same period. Were a hypothetical exoplanet to find itself in the Castor system, its inhabitants would have enjoyed rather bizarre natural phenomena. For example, the planet would receive light from several stars at the same time, so there would be several sunrises and sunsets a day. At least it seems bizarre and exotic to us, as we live in the light of only one star. If the Sun had a companion with similar parameters, the Earth would get twice as much heat and light with all that it implies, and the sky above us would have a totally different aspect. And it is hard to imagine what a sky with several stars like our Sun would look like. This mind-boggling sight is straight from a world of fantasy. But that's what we would see if we were to find ourselves in the Castor system. We really appreciate our audience, guys. That is why we do our utmost to provide a high-standard video every time. It takes a lot of time and effort to create a new one, and your support by liking and subscribing to the channel means a lot to us. I hope you enjoy what we do and you will hit the like button or leave a positive comment. And we will do our best making new videos for you to check out and learn from. Let's keep in touch.